Hello, grade 10 science students. So yesterday we talked about the ray model of light, and today we're going to talk about the laws of reflection. So the laws of reflection actually allow us to determine how things are going to be seen and kind of predict how light is going to react when it's against a certain surface. So if I am using light laws, I need to understand some very key specific things. The first one is that our angle of incidence, so where that light ray is entering the plane, is going to be the same as the angle of reflection. So, for instance, if my light is entering this mirror here, and this is my normal, and the reflection line is right here, the angle of reflection and the angle of incidence, those are the same value. And this is because it's making that 90 degree against that normal, okay? This law only works if the normal is 90 degrees to the mirror. The second one is that the incident ray, the reflected ray, and the normal all have to be in the same plane. So here, if I'm looking at it like this, you notice that my incident ray, my reflected ray, and my normal are all on that same plane. So if you imagine that like my mirror surface is my y-axis, or let's do x. So my mirror surface is my x-axis, then this is all my y-axis, okay? So this is all on that same plane. And you'll recall that we talked about that yesterday in this image, okay? So if we were in class right now, I would do a demonstration with aluminum foil, but we're not. So I'm going to try to find a YouTube video to throw in there. But basically what happens is that you guys can try to do this at home. So take a flat piece of aluminum foil, and I want you to shine a flashlight on it. So you might need to dim the lights a little bit. So shine a flashlight on it and see where the light bounces off, okay? So dim the lights, shine the flashlight onto the flat piece of aluminum foil. And what you should see is that you actually, if I was shining my light from here, it's going to come down, hit the surface, and come up kind of over here, okay? So I want you to try to actually do this. Whenever we have this, it's because we're reflecting off of a flat surface, and it produces these parallel incident rays because of that flat surface, okay? And if I'm producing parallel incident rays, then I'm going to have parallel reflected rays, okay? We call this specular reflection, and this is what you're going to see in that flat piece of aluminum foil. Now, I want you to take the aluminum foil, I want you to crumple it up, and then don't really smooth it out, but like pull it out a little bit so that it's not a ball. And we're going to still talk about this. The laws of reflection are still going to apply, but when you shine that light, so I want you to shine the light at it like this, you're going to notice that it's not the same as if it was flat. And this is because our incident rays are hitting all of these different types of surfaces. So they're making all of these different angles with these surface because the surface is not flat. Okay, so I'm having one incident ray come up, I'm having another one shoot wide, another one come short, and it's because they're bouncing off and they're scattering in various directions. Okay, so this is what's happening here with that crumpled up aluminum foil. Call this diffuse reflection. Okay, so this is going to be called diffuse reflection. This is basically today's lesson. You do have some reading to do, so I'm going to toss those textbook pages are on there. You're going to do number 1 to 6. Again, try to do this little experiment or demonstration if you can at home. But it's really important that we understand how this works, okay? So you only have 2 lessons this week because it's a short week. You should have lots of time to work on things. Let me know how things are going. I hope that everyone is doing well.